Hello, welcome to lecture 15. First, we're going to be defining solutions. For the following cases, we're going to decide if a solution is made. If a solution is made, we're going to identify the solute and the solvent. So first, we're looking at 5.0 grams of sugar. It's dissolved in 100 milliliters of water. So we decided that yes, it can be dissolved, so it is a solution. Decided here that the sugar is the solute and water is the solvent. Now we're going to look at 5 milliliters of olive oil that's mixed with 100 milliliters of water. This is not a solution. The oil and the water cannot mix. Next, we're going to be looking at the mighty power of the little water molecules. Water is a common solvent for ionic compounds and polar molecules. So I'm going to explain in my own words the properties of water that allows it to solvate or become a solvent for these compounds. So the explanation to this is that the shape of the molecule is bent, and because this makes it very polar, other ionic compounds and molar molecules are attracted to it. Also, because it is so small, it could easily surround other ions and molecules and easily separate them apart. This is how it is a solvent for ionic compounds. So because like can dissolve like, I'm going to let you know how the next compounds will be able to be dissolved in water, or if they will be able to be dissolved in water. So for the first one, we look at salt of clindamycin antibiotic, and yes, we can it can dissolve in water because it's an ion. So ions can dissolve in water. Like will dissolve like. And then for this one, I2, it will not dissolve because it is nonpolar. I and I are nonpolar, so no, it will not be able to dissolve. Nonpolar and polar will not dissolve in water. For the next one, we are going to talk about electrolytes. Electrolytes can conduct electrical current. We're going to indicate whether a solution of the following will consist of only ions, only molecules, or few ions with mostly molecules. And then we're going to write a balanced equation for the hydration reaction. So first, we're going to start off with sodium chloride. And it's a solid, so we put in parentheses, S in parentheses. Next, we draw an arrow to let us know that we are putting water into the mix, into the reaction. So what will happen is the sodium chloride will be dissolved by the water, becoming sodium and chlorine, two separate molecules. So now we're going to be talking about units of charge. We're going to be talking about how a unit of equivalent is used to state the moles of positive or negative charge. An equivalent of an ion is the amount of that ion to give 1 mole of a charge. State the amount of equivalents for the following species. So first, what we're going to do here is figure out what our conversion factor is, and our conversion factor is equivalents over moles. So for this one, because we want to end up with equivalents, we're going to start off with moles because that's our given. Our given is 1 mole of calcium to positive charge. So we're going to start with that. We're going to write the conversion factor with the moles at the bottom and the equivalents at the top. So 1 mole of calcium to positive charge is 2 equalities because of that positive charge. That positive charge is 2 equalities. So with 1 mole times 2, because the moles will cancel out, leaving us with 2 equalities. Now we're going to try to do 0.5 micromoles of sodium. This one's a little bit more difficult because we're going to have to use 2 conversion factors. So we're going to start out with our given, which is 0.5 micromoles of sodium plus, with the positive 1 charge. We're going to use the conversion factor of 10 to the negative third moles over Na plus over 1 micromole of Na positive. That will cancel out the micromoles. Then we're going to use the conversion factor of equality, 1 equality over 1 mole of sodium. We only have 1 equality because there's only 1 positive charge. When we multiply everything out, we are left with 0.0005 equalities. For our next one, it's going to be similar to the last. We're going to do 4 micromoles of chlorine. We're going to start off with a given 4 micromoles of chlorine. We're going to write the conversion factor of 10 to the negative 3 chlorine over 1 micromole chlorine. We're going to multiply that by the conversion factor 1 equality over 1 mole of chlorine. Once we cancel out all of the units, we're going to be left with 0.004 equalities. For the next one, we're going to start off with our given 2 moles of iron with a 3 positive charge. We'll start off with our given 2 moles iron, 3 positive charge. We're going to multiply that by the conversion factor of 3 equalities because we have 3 positive charges right there over 1 mole of iron 3 plus. We are left with 6 equalities. Next, we're going to be doing the limit of solubility. Even though solute compounds can be soluble in a solvent, there is a point where the solvent cannot take any more solute and the solute remains undissolved. At this point, the solution is saturated. Take, for example, at 20 degrees Celsius, sugar has a solubility of 204 grams over 100 grams of water. So A, if you add in 100 grams of sugar and 50 grams of water, will the sugar dissolve at 20 degrees Celsius? So for this problem, we start off with our given, which is 50 grams of sugar. And then we use our conversion factor, which is 204 grams of sugar over 100 grams of water. So when we write that out, and we cancel out the grams of water, we are left with grams of sugar, and we're left with 102 grams of sugar. Now, since we only added in 100 grams of sugar and 50 grams of water, we have 2 extra grams of sugar left over, which means that the sugar will dissolve completely into that formula. So yes, the sugar will dissolve. So if we add in 200 grams, we just subtract the 102 grams that we figured out from before, and we're going to be left over with 98 grams of sugar. So 98 grams of sugar is what will be left in the solution. So next we're going to be talking about the solubility rules. Not all compounds will dissolve in water. In the case where the ionic interactions between the cation and anion is too strong for water to pull the two apart, that solid is said to be insoluble. Use the solubility rules to determine if the following species are soluble in water. So for these, we just go to the solubility rules. Now, ammonia and chloride say that it's soluble together, so they're soluble. Lithium and hydroxide are soluble together. Lead chloride is insoluble. Calcium hydroxide is also insoluble. So when all else fails, check your solubility rules, and they will never fail you.